Hello viewers, so welcome back to this course on matrix computation and its application. So this is the last lecture of this course. So in this lecture we are going to solve some examples using the Householder transformation to find out the QR factorization or the tridiagonalization of a symmetric matrix with the help of Octave. So let's do that one. So, in the application of the Householder transformation, as we have discussed in the previous lecture, that and we have defined this as 2W transpose by this one. Now we are going to use the application, and this first one is the QR factorization. As we have already seen the QR factorization with the Gram-Smith process, so in this case also we have the matrix A and multiplying by some this Householder transformation, and on the right hand side I will get R. So, this R is a upper triangular matrix. So, in this case what we get is that, and this is H1, H2 all are, I know that this is orthogonal matrix. So, I can find from here, then this can be written as Hn minus 1 H2 H1 inverse R. So, inverse means this is equal to transpose, and I can write this as a H1 transpose H2 transpose and Hn transpose R, and I know that this is symmetric matrix. So, it becomes H1 H2 Hn, and this is the orthogonal matrix. So, product is also orthogonal. So, I will get QR. So, my A is QR. So, this is the QR factorization of the given matrix. So, let us do this one in the Octave. And now suppose I will take the matrix. So, let us take the example of this one. So, I will just take example, and let I take the matrix A. So, this matrix I am taking here is that is 4 1 minus 2 2, then 1 2 0 1 minus 2 0 3 minus 2. So, I am taking the 4 by 4 matrix just to, and this is I am taking 2 1 minus 2 minus 1, and you see also that I have taken A transpose A. So, I have taken the symmetric matrix because we are going to use this one. So, this is the matrix, and first is that solution is that find its QR factorization using Householder transformation. So, this is what we are going to do. So, let us start with the Octave. So, I have saved one script file with the word Octave. So, now we know that we start with clear and CLC, and first of all I should write here that Householder transformation. So, this is what we are going to do. So, first of all I will find I will write my matrix. So, this matrix we are writing here is 4, 1, minus 2 and 2. So, this is in the first row, and then 1, 2, 0 and 1, this is second row, and then minus 2, 0, 3 and minus 2, and then I am taking 2, 1, minus 2, minus 1. So, this is the matrix we have defined. So, after defining this matrix, now I want to start my householders. So, I can say that using first column. So, I am using the first column. So, now what I am going to use it here, that now from here first step 1 is that now I will take my first vector. So, this is the vector I am talking about. So, this is I am using 4, 1, minus 2, 2. So, this one I am going to use, and from here I will make this vector, transform this vector into some value here and 0, 0, 0. So, this is what I am going to do with the help of this one. So, now I am going to use the first column. So, let us write this one. So, let us take column 1, I write it C1. So, in this case I am writing C1 is A, first all the and first column. So, all the rows and the first column. So, this is my C1. Now, I define my n as the length of C1. So, this is my n I am defining it. Now, I know that I need to define the norm also. So, in this case what I am going to do, I am going to define new C1, because I am dividing the C1 by. So, in this case I will divide the C1 by the norm. So, norm I will take of what? C1, and I want to take the maximum norm or the infinity norm. So, I write inf. So, this norm I am defining this one. So, this is my new C1 I will get. So, once I will get the new C1, now I want to define W1. So, W1 you know that this is new C1. So, this is my new C1, plus now I will take the sign. First I will take the sign of, now you can see that I need the sign of this new C1, the first component, only first component. So, that is what we are going to see, the sign of the first component, star, multiply this one. What I need to do, I need to find the norm, the length of this. So, I am defining the norm of new C1. So, this is my new C1, So, that is my new C1, and I am taking the two norms of this one, and then I will multiply by the vector, identity vector. So, I will write I. So, this is the command, but I want the vector of length. So, n should be the number of rows and only one column should be there. So, this is the basically we are getting the vector, the column vector. So, this is what we are going to find W1. And now, once I find the W1, I will get the. So, you can write from here in this case. So, this is you can write here as vector W, and now this one I can write finding the householder matrix H1. Why we writing this H1? Because first I am dealing with this one, so I will find the matrix. So from using this one I found my W1, and then I will find my H1 and then multiply the H1 with this vector, and I will get some value here 0 0 0, and then I will find out H1 and my A, the matrix A, and I will get the new matrix, that is A1. So this is what we are going to do. So now I am finding my H1. So H1 is equal to, so I need to find out, because you will see that H1 is going to be 4 by 4 matrix. So I need to define my identity matrix. So identity matrix is I of order n, because it is n is the number of length, so it is 4 minus, so I will write here 2 star W1 star W1 transpose. So this is what I am going to take, and now so this is the value we are going to take. So maybe I will define this one, divided by W1 transpose multiply by W1. So this is what we have defined. So that is my H1. Now I want to see that what will happen if I take H1 and I will multiply this one with a new C1. I will see this one. So I can define this as new C1. New C1 I will define. So maybe I can define it, just put this value here, and then from there I will find my new A. So new A, or maybe I can write this as my A1. So A1 I will get by multiplying H1 with my matrix A. So let us see that whether it is going to work till here or not. So first I will save this value, and then I will run this one. I will change the directory, and let us see any mistake is there. So okay, so no mistake is there. First I have taken this matrix. So this matrix is 4 1 minus 2 2 1 2 0 1 minus 2 0 3 2 3 minus 2 and 2 1 minus 2 1. So that's okay. Now I have taken from here, I have taken this column. So you can see the first column we have chosen. Now n is 4, and if you see this one, now if you see I have chosen the new C1 and just I have written this value. So it will not display the. So now you can see from here, I just again run this code, no problem, this one. Now you can see that 4 was the maximum value. I dividing by C1 by 4, so I get 1 here, 1 by 4 is 0.25 minus this, so I get this new C1. So this is a scaled one. We have scaled this vector, and after this I get my W1. So W1 we have taken that new C1 plus, so sign of this is positive, so we have taken the positive sign. The magnitude of this one we have taken, and then E1, so we got this W1. And after doing this W1, so W1, if you see, this is my I call it C1. So, and then I will convert this into the new C1. So, it is new C1 plus sign of this is positive. So, I am taking the new C1 norm and then E1. So, this is what we have done, and after that my H1 become this one. So, once I take this H1 and applying on the vector, you see that this value becomes minus 1.25 and this value is 0, 0 and 0. So, both are, all the three values become 0 now, and I apply this on the A matrix. So, A1 is the new matrix with the first column a new vector, and then here it is 0, 0, 0. So, this is what we got. So, my value of this A1 is this value. Okay. So, now let us see. So, up to here we are able to find out the householder matrix and its application transformation on the new C1. So, this is what we are able to finish. Now, let us do that one. Now, applying on the next column. So, in the next column what we are going to do is, in this case, after doing this one, now I am going to choose the next column, and this part we are going to choose then, because we need to take now this element 0, 0. So, we are going to use here 2, 0, 1. So, this is my next step. So, after getting this value, now we have to take this vector 2, 0, 1 as a new vector. So, I am going to take here 2, 0, 1. So, let us take this one. Now, I take my C2. So, again I am taking my C2, but in this case I am taking my A. So, whatever the A we got, this value, and now I am taking it from 2 to n, whatever the n. So, it is 2 to 4, and then this maybe second one. So, that is my C2. Now, everything will be again, it will be same. Now, I will get this, maybe I can copy this one. So, I will get control C and I will putting it here, control V. So, it is my C2. Okay. This is my C2 and this is my new C2. So, I have found from here this value, taking the infinity norm means the maximum C2 and then divided by this. So, I got this value. Next one. So, I need to find now W1. So, I will also copy this, control C, and I will put it control. So, now this is my W2 I am going to define. So, now it is C2, sign of new C2, the first one. So, it is, in this case it is positive, the norm of new C2, 2 norm we are defining, and now we see that it is 3 cross 3 matrix. So, I have to take minus 1, 1. So, this is my vector, this one. So, this is my W2, and now after this one we find the householder matrix, control C, put it here, control V. Now, everything will change here. So, 2, now this matrix is 3 cross 3. So, I will take the identity matrix, and now it is 2, 2, 2. So, this is my H2 now, and after this one I will put my H2 and I will define this on the new C2. So, let us see that what will happen in this case, and after that I will define my, so A1 is there, now I will define A2. So, A2 will be, now see what is going to happen is now, so these things we have to keep in mind. Now, this is a 3 cross 1. So, in this case now what I am going to do is, from here I define my H2. So, H2 will be 3 cross 3. H1 is 4 cross 4, but now it is a 3 vector 3 cross 1. So, H2 is my 3 cross 3. I can just call it this one, or no, not so. So, I will just write here, I just call it this one. Now, I can choose my H2 as 1 0 0 H2. So, then now it is 4 cross 4, and what I am going to do is, now I will take H2 over A1 and I am going to get A2. So, it means what I am going to do is A H1 H2. So, this is what we are going to define. It means now I have to take my H2. So, I just should write, instead of H2 I should write H2 temporary. So, this is what we are going to take, temporary. Now, from here I will find my H2. So, H2 is, there is a command for block. So, that is the block diagonal. Basically, we are defining the block diagonal here. So, first one is the first entry is 1, and then I will define H2 temp. So, this is what we are going to define. So, that is my H2 now. So, let us try to find out. So, this is my, if you see, A1 is whatever the A1 was there. Now, C2 is my 201. This one, just wait, it is, I think we should take 1, because the new A1, and then it is okay, yeah. Let us see now. So, see from here, first we started with this H1. So, A1 is this one. Now, we are dealing with only this one, this part, because whatever the A1 are getting, now we have to choose this one. So, C2 I have taken first this one, then this value, then this value, and now from here I will scale down. So, this become 1, this value, and from here my W2 is becoming this value, and then my householder matrix 3 by 3 will be this one. So, it is, you can see it is symmetric matrix, and then I am applying on this vector. So, I get this vector here. So, first component is non-zero, other is 0, and from there my H2 matrix become this one. So, that is my H2 matrix. So, you can see that this is my the 3 by 3 matrix, this is H2 temporary, and one value, this value. So, now from here it is okay. So, we are, whatever the work we have done is right till here. Now, I will get my new matrix H2. So, this is my, I am applying my H2 on A1. So, this is what we got, and I got my H2. So, now after doing this one, so now you can see from here that if I want to make this matrix as a QR factorization. So, now what I am going to do is that I will take next this part, because I will make this one is 0 here and this become the upper triangular. Basically, I want to convert this A into the upper triangular matrix. So, again I have to applying this one more time. So, I can write applying to the next column, this one. So, everything will be same except changing this values here. So, what I am doing now, I will copy all this, Control C and put it here, Control V. So, let us see what is going to find out here. Now, my C2 I will take here C3, and this is coming from the A2, the new matrix, and now it is from not from 2, from 3, and this should be 3. So, that is there, and after this I will get the 3 here, and this is my 3 here, and this is new C3 after the normalization or the scaling down. Now, I will get W3. So, W3 is there. Now, I will take C3 sine of C3 norm of C3, and now it is 2 cross 2 matrix. So, I will take here n minus 2 1, and now from here I can start my Hausholder matrix. And this is n minus 2, and this I will take H3 temporary, and this is H3 temporary, and then I will take new C3. So, this is I found from here. Now, I find the last matrix A3. So, for this one I need to find H3. So, H3 now it will be again the block matrix. So, I can write here BLK. So, it is the block diagonal matrix. Now, I have to define 1 1, because in this case it will be only H3 temp is 2 cross 2. So, I will write H3 and this matrix. So, that is my block matrix, and if I apply this H3 on my A2, so I should get the upper triangular matrix. So, let us see this one. So, now after getting this, so this is my C3 we have found now, because I need to find this value 0 here. So, my new C3 is 1.5, so I divide by 1.5, I will get this value. W3 I will got this value, and then using this W3 we have made the Hausholder matrix, that we call it H3 times, that will be 2 cross 2, and if I put this one I will get this value here. So, you can see that it is 1.1 value something, and this is a 0, e raised to power minus 60 means 0 value, and then my H3 becomes, so I put this matrix here, and this is just the block diagonal matrix we got, and now we applying this on the A3. So, you can see that this became my new matrix, and that is upper triangular matrix. So, after doing this one I got my upper triangular matrix. So, this is my upper triangular matrix, and now if you see from here I can find now the final upper triangular matrix. So, I can write from here that R, or I can write upper triangular matrix. So, that is what it is? It is, I can write directly here. So, if you see from here, this is H3 multiply H2 multiply H1 and applying on A. So, this is same as S3O2. Now, what we want to do? We want to compare this one with the inbuilt function. So, inbuilt function is that, so I can write that compare with the inbuilt QR function. QR function. And what is that? So, that is, we write it Q R. So, this is what we get from here, and I will write QR of matrix A, and then we can check. So, this is, let us see. So, this is my upper triangular matrix. You can check, this is same as this value. So, we have done this one in the steps, and this is the value we got. Now, we have applied the QR factorization inbuilt function. So, in the inbuilt function, if you see, this is my, from the household, this is my Q matrix, orthogonal matrix, whatever we got. Now, from here the R in this case is same. If you see, it is minus 0.5, 0.5, minus 1.6, same value it is coming. You can see from here. So, it means that we are able to find our transformation. So, whatever the transformation we have defined and using this one, so the upper triangle matrix is going to be same in all this case. So, we can say that we are able to convert this into, after this I am able to convert H3, H2, H1A into R. So, it is upper triangular matrix. Now, we are able to do this one. So, now I want to define the another application, just one extension of this one. Now, I can say application 2. Now, suppose my matrix A, that is n cross n, is a symmetric matrix. Then I can convert the matrix, then matrix A can be converted into tridiagonal form. So, tridiagonal form means, suppose I have the matrix A and that is symmetric. So, I will get the values only at the main diagonal, one diagonal below this, one diagonal above this, and all other values 0. So, we can transform this matrix into the tridiagonal form. So, these things we can do. Here we can write that, suppose I have the matrix A, I can apply my H1 left side and the right hand side, H2, H2, H3, H3, and suppose it is going up to Hn. So, after doing this one, whatever the value, we get the matrix, that is, maybe I can write some R, or I should write it T. So, this is tridiagonal. matrix. So, the same way we can define here. So, now if you see, I have chosen this matrix A to be the symmetric matrix. Now, so the same way we can do, maybe I can define it here. So, let us convert it to tridiagonal form. Matrix. So, nothing we have to do in this case, only thing is that if you see from here in the tridiagonal, the first vector, the same matrix is there 4 1 minus 2 2. So, in this case the first vector we have to choose this one, because I need to keep this element here and then I have to make this and this 0. So, only one less step we need to do. So, in this case we can apply the same matrix. So, maybe I can write maybe another, and I will call it, let us call it tridiagonal form. Using householder. So, I just write it and save it on this one. So, what I am going to do is just I will going to copy this, and now I will just copy this matrix. Let us go up to this, Control C, and I will put it here, Control V. So, this is okay. Now, first column, if you see, now the first column I have to choose here from 2 to n. So, this is what we need to do. Maybe I need to find this value here. So, I will take and I will put Control X here, Control V, and I will find out here, maybe I will shoot the length of A and I should first column. So, this is what I can do, no problem. Now, C1 I will choose from 2 to n 1. After that, new C1 is okay, the same way will go. W1 is also same. Now, I will go by this way. If you see from here, so this will be n minus 1, because now I am taking 3 by 3 and finding my H1. So, H1 is okay. Now, it should be n minus 1. So, I will take this as H1. So, I will call it this as temporary. And then you will see this one H1 temporary and new C1. So, that is my, and now from here my H1 will be block matrix, and then I am finding 1 here and H1 temp. So, this is what we are able to do. So, let us see this one. So, now you see from here A, this one I am taking 1 minus 2 1 dividing by the 2. So, this is the value, and W1 I got this value. So, my H1 temporary, this householder is this matrix, and applying on this one. So, I am getting 1 minus 1.5 and 0 0, and this my H1 should be 4 cross 4. So, it is this value. So, that is okay. So, we are able to find this matrix, and now you can also check that H1 star A will be this one. So, now we are getting value 4 here, minus 3, and then 0 0. In the next case we have to make this value 0 only. Okay, so now let us see what is going to happen if I take H1 star A star H1. You see here, this is also becoming 0 and this is also becoming 0. So, now next step is only one step is remaining. So, this is okay. Now, from here my A1 is, I can write my H1 star A star H1. So, this is what we got A1. Now, I need to find my next part. So, this is the next things we can do again the same way. So, maybe I should go up to here and Control C, put it here, Control V. Maybe I can define here next column, and then now I can define my. So, this is just I will take 3 and this is my C2. Now, I define my new C2. So, everything is again same C2 and norm of C2. Now, I can find my W2. So, W2 is new C2 and then sine of new C2, the norm of C2, and this will be 2 because it in the matrix will be 2 cross 2, and then I will find this value. So, it is my 2 2 2 2, and this matrix will be also 2 cross 2. So, this is what I got this one, and if I apply on this one I will get my vector this. So, just it is to check here, and once I get this matrix, now I can find my H2. So, H2 will be again the block matrix. So, BLK, and this is 1 1 and H. Sorry, I should write it here, H2, and this is H2, and this is my H2, this value. So, this is my H2 now, and now from here I can find my tridiagonal matrix T. So, T is my tridiagonal matrix. So, that will be H2 star A1 star H2. So, we will see that this is going to be our tridiagonal matrix. So, let us run this one, and now you can see that my. So, after that A1, and now I take C2. So, C2 is basically we need to take from, no we have to, C2 should be from A1, that we have to keep in mind. Let us run again. So, my C2 I am taking minus this one. Okay, 1 second. let us see again, because I need to take this now it is okay, it is 1 and 1.33, we have to take this one, C2 dividing by 1.33, so it becomes 0.7 and 1, W2 is now 2 and 1, and my householder transformation is matrix will be this, and if you put this one, you see that here we got the value 0, and now my H2 will be this value. I am putting this my household transformation here and put my H2 here, and now if you see from here, my tridiagonal matrix is now it is 0 here, 0 here, 0 here, 0 here, next is 0 here, and this is 0 here, and the remaining will be the tridiagonal matrix. So, you can check that this is a tridiagonal matrix now, and we are able to solve this one with the help of householder transformation to convert a given symmetric matrix into the tridiagonal form. So, by this way, in the computer programs, you know that it is quite easy. Once we write the program, then we can just change the matrices, and the same program can be run for various type of matrices. So, that is the benefit of writing the code to do the numerics. So, I think now this is, we should stop here, and now with the help of this code you can write your own codes, and then you can verify or you can try these things for different type of matrices. So, let me stop. So, in the lecture we have discussed the application of the householder transformation. First we have shown the QR factorization, and then we have another application we have shown that if the matrix is a symmetric matrix, then we can convert this one into the trigonal form using the householder transformation, and we have taken the help of Octave to do all this computation. So, I hope that you have enjoyed this course, the complete course on matrix computation, and I also hope that you enjoyed and learned a lot of things from here that will be useful for your further studies. So, thanks for taking this course and completing this course. So, thanks for taking this course. Thanks very much.